Okay, I'm going to work out several here, and if you could do all the problems that I work out, you are definitely going to do amazing on the Celebration Friday. Okay, let's get rolling. All right, the first several are going to utilize these, sum up functions like these ones. These are from that review sheet. Okay, so we need to be able to multiply functions together. So probably we'll think this is pretty easy. And so you can, fast forward to something that you might need. So this one would just be FOIL. So we just multiply these together. And then we do the outside. And then we'll do the inside. So that was the outside, inside now. And then we're going to do the last terms. So that would be -6. So that would be fine. Or, of course, you can put it in order, highest to lowest. So highest to lowest degree, typically. Okay, so that would be your best answer there. Next one, you need to be able to add functions together. So if we add 3x plus 2, we would add h of x, so that would be -x minus 5. Add your like terms, so that would be 2x, and then -3. You'll want to, now you do have one like this, so the way this one works is you work from the inside out. So first you figure out what g of -2 is, so here's your function g of x. So you can say, okay, I'm going to figure out what g of -2 is. So g of -2 equals, and you just plug -2 in for x. So that would be -2, we would square it, and then -3. So -2 squared, so that's 4 minus 3. Just remember, if you have to put that in your calculator, you need parentheses. So that would be 1. So that means we're going to be able to replace g of -2 with a 1. That would be f of 1 plus 4. So that means now it's going to be, what is f of 5? Because we'll just add those two together. So now we go back up to the f function and we plug in a 5. So that means it's going to be 3 times 5 plus 2. And that's where we get 17. Okay, this one is when you take a function, put it inside of another one. It's composition of functions. So I like to just replace the function on the inside. So f of x is equivalent or equals 3x plus 2. So I'm just going to substitute f of x for 3x plus 2. And then we're just looking for what is h of 3x plus 2. That just means you're going to plug the 3x plus 2 in for wherever there are x's in the h of x function. So it would be minus, and instead of the x, we're going to put 3x plus 2, and then minus 5. And then we'll just kind of clean it up a little bit. So we'll distribute, so minus 3x, minus 2, minus 5. So then that would be minus 3x, and then minus 7. Okay, this one pretty similar. You work from the inside out. So f of 4, so let's figure out what f of 4 is. So just off to the side, you can say, okay, I'm going to figure out what f of 4 is. Plug a 4 in there. So that would be 3 times 4 plus 2. So that would be 14. So that's f of 4 equals 14. That means we're going to replace the f of 4 with 14. So now it's, hey, what's g of 14? So we're going to plug a 14 right in there. So that's going to be 14 squared minus 3. So we know that 14 squared is 196. So 196 minus 3. So that would be 193. Okay, then we have a little division. So we take the j of x, which is this 9x squared minus 4, put that over the f of x, which is 3x plus 2, and then we'll most likely have a little bit of factoring that we can do. So the top, we can do a little double bubble. It's a difference of two perfect squares. So 3x minus 2, 3x plus 2, and then, of course, we'll be able to cancel out the common factors. That will leave us with 3x minus 2. Okay, this is a question. It says, which function has the same x and y intercept? So we've done this one a couple of times, or at least I have. So 2, 0, and 0, negative 2. So what we would have to do is we would have to look at each of these functions to see which one has the same x and y intercepts as this line does. So to find the x-intercept, we're going to plug in a 0 for the y. So that's going to, and I'm going to actually choose the right answer again here. So I'm going to go 0 equals 4, 2 raised to the x minus 16. 0 equals, I'm going to add the 16 over. So 16 equals 4 times 2 raised to the x. Now here what we need to do is we want to isolate the exponential part. So we're going to divide by 4. So that's 2 to the x. We're going to divide that side by 4, so that equals 4. So 2 raised to what would equal 4, and then you can just tell that that would have to be a 2, because 2 squared equals 4. So that means the x-intercept would be 2, 0. That's what we're looking for. And now we need to figure out if this same function has a y-intercept of negative 12. So to find the y-intercept, you plug a 0 in for the x. So let's do 4, so let's say y equals 4, parentheses 2 raised to the 0 minus 16. Y equals, we know anything to the 0 power is equal to 1. So that's 4 minus 16, or y equals negative 12. That means your y-intercept is 0, negative 12, check. So this is the one that does it. The other two might have one or the other. They might have an x-intercept or a y-intercept, but not both. Okay. All right, this is the one where I have told you that you're going to look for the one that has a bigger number in the parentheses. That's going to show that it has a more rapid rate of change. Because when you multiply by something, in the parentheses, up by a bigger number, it's going to make it more steep. And so we're going to just look for that. So it's going to be this guy. Even though the little outside number is a little bit smaller, it can be. Okay, this one you're probably going to need to, we have one graph and then we have one equation. Probably going to need to graph that on the calculator, the one that you don't have a graph of. And this particular one kind of looks like this-ish, okay, when you graph it. And I sort of messed this one up on the sheet because they actually have two answers. So I sort of made up this problem and I made it up and made a mistake. So which statements are true? This one's true and this one's true. So they do both have a y-intercept of 9. So this one hits right at 9 too. You can tell when you plug in a 0 for the x, that turns out to be 9. So they're both 0, 9, okay? This one's 0, 9. Okay, the other thing that's similar is the end behavior on one of the sides. So as x approaches infinity, negative infinity, sorry, the y value approaches positive infinity. You can tell the same thing on this side. As x approaches negative infinity, the y approaches positive infinity, okay? It's not the same on the other side. One goes sort of approaching the x-axis and the other one goes up high. So A and B. All right, now this one we have two functions. One is the graph here on the right and one is this one. What we want to do is kind of compare the domain and the range. So this one here has a domain that is just numbers that are 0 or bigger you're allowed to plug in. This one is a little bit shifted. It was shifted 2 units to the left. And so it's going to have a domain that's all the values from -2 and bigger. So a little bit different domain for these functions, and the range actually is the same for both. So they have, this one starts at 1, and you can tell that if you plugged in a 0 right here for this function, if you had a little XY table, of course you can just graph it on your calculator, but if you plugged in a 0, then that would be 0, 1. That would be the start of your Y values right there at 1, and then they would just keep climbing from there, same as this one. So what we want to try to do is write this sort of in words, so that's going to be, a little bit different for us. So we're going to say something in words like the domain of the equation is is 0 and greater than 0. The domain for the graph is -2 and greater. And the range is the same for both graphs. The range is 1 or bigger, 1 or greater for both graphs. Both functions, I'll say. Okay, so try to kind of describe it in words. You won't have like an amazing, equation editor or anything to plug in, and just type it in words, okay? All right, this one, we want to see where they're both decreasing. I don't know why that little piece got taken out, but we want to look to see where they're both decreasing. Now this function is just a line, so it's just a line that looks like, it's in slope-intercept form, so we just go up to 3, put a dot. You can tell your slope is -2/1, so it just goes down 2 and over 1, so it looked like this. You don't really need to know exactly what it looks like. I mean, it has a negative slope, so it's decreasing all the time. So really, we just need to figure out where this guy is decreasing, and that's the interval we're going to look for. So this one's decreasing this whole time, so that's everywhere from a value of 2 all the way, to the right. So that's why we want to choose this one here, because that would be where both graphs are decreasing from 2 to infinity, okay? Okay, this is our real world piecewise function, so this is pretty easy, really. You just want to put the inequalities, correct here. So the hour for the first company, you can tell this one's $4.99, this one's $6, so of course company B is more expensive. For each additional hour, you can tell there's a little bit of an increase here from $4.99 to $8.49. So just do that subtraction real quick and see what that is. So $8.49 minus $4.99, that's $3.50. So at least that one went up $3.50. They might go up, different amounts as you go, but this one's $2 for each additional hour. So I would say, company A is more expensive for each additional hour. And then finally, which one's more expensive for the 24-hour rental? This one only goes up to 20, and this one goes up to 20.25. So then we have greater than going that way. So remember, it opens to the bigger amount. All right, little real world question here. So we're just trying to figure out what would represent the profit. So profit would be taking all of her sales, when she has sales, that's similar to like your revenue. This is the money that you have coming in. And then expenses is kind of money going out. So sales, money coming in, expenses, money going out. So profit would be taking your sales, your S of M, and then subtracting the expenses. So subtracting the E of M. Okay, that would get you your total profit. So in the profit, I'll just say profit would be equal to that, okay? And then it says, hey, can you write like a function for profit, P of M? So let's go ahead and figure out what that would be. So P of M equals, and we would have to actually subtract those functions. So we're going to take the sales, this one here. So let's do 1050 M plus 820, and then we would just subtract the E of M. So then we would just subtract 340 M plus 900, and then just make sure you put it in parentheses so that you can distribute the negative sign. So P of M equals, and then we just can subtract this. So that would be 1050 minus 340, so 710 M. And then we'll go ahead and just do 820 and then minus the 900. So minus what, like minus 80. Okay, so that would be our P of M function. All right. Okay, this one, we're trying to look for, select all the statements below that are false about these functions. The slope of g of x is negative. Okay, so let's try to figure out what the slope is of this. I would probably, just whenever you can just plot points. So I'm just gonna plot these points that are in the table. So I'm gonna do a quick plotting of the points. You could just do this on your scratch paper. So do a quick plotting of the points. Okay, so let's say the graph kind of looks like something like that. Okay, and also you can tell the graph is kind of going, when you do plot the points, you could tell your graph is going up 2 units and over 2 units. You're going up 2 and over 2. So that means your slope is going to end up just being 1. So m equals 1. Now you can also just calculate your slope. So you can take any 2 points if this is truly linear. They are 2 linear functions. So you could always subtract the y values over the x values. So remember, you can take these y values, so you can do 3 minus 1 over 5 minus 3, and you can see that would be 2 over 2, which is a slope of 1 as well. Okay, you're just subtracting your y's over your x's. All right, so slope of g of x is negative. That's a no. So this is your g of x, the one that's a table. The y-intercept is the same for both functions. This one has a y-intercept of 1, and this one looks like it has a y-intercept like of -2, so no good on that one. Oh, I was supposed to look for things that were false. Oopsies. So those 2 are false. Okay, so far so good. Those are the ones that are actually false. The slope of f of x is smaller than the slope of g of x. So this one is smaller than the other one because that's a negative number, and negative numbers are smaller than positive numbers. The intersection of the 2 is 1, -1, and that is correct. So I didn't plot this graph yet, but if I do, there's 1, that's your y-intercept, and then you would go down 2 and over 1. So it would intersect right at the spot they say, the 1, -1. So we picked the 2 that are false. All right, this one, we're looking at which one has the lowest minimum value. So, your celeb could have a maximum value, really similar. So you need to know like how to find the vertex. So the vertex form here, you can tell it's always set up, remember, in the f of x equals a and then x minus h, quantity squared plus k. And we know hk is the vertex, okay? So in this case, the vertex is -3, -7. So that tells you that the -7 is the lowest point, and you can see this one has a lowest point of -3 because it looks like it's right at 2, -3. We're just focusing on the y coordinate. So we would say that, kind of in words again, kind of like that other one, we would say f of x has the lowest minimum because the y-coordinate of the vertex is negative 7, which is less than negative 3. That would be great. Okay, this one we just want to add the functions together when x is negative 1. So you can really do it two ways. You can plug in negative 1 into both of those first, or you can plug in negative 1 after you've added them together. So whatever you like. I think this time I'll plug in the negative 1 first. So let's plug in negative 1. So we're going to have f of negative 1 equals 2, and that would be negative 1 raised to the 4th plus 4 times negative 1. That would be negative 1 to the 4th, of course, is 1, so that would be 2. This would be negative 4, so that's negative 2. Okay, so this part would be negative 2. Then g of negative 1, so that means I'm going to put g of negative 1 equals, and that would be negative 1 squared plus negative 1 minus 3. All right, so that's 1 minus 1 minus 3, so that would be minus 3 overall. So that would be minus 3, and so I'm going to put minus 3 right there, and so this answer would be negative 5. What about when x is 0? So we could do f of 0. So f of 0 is equal to 0, because it would just make all that 0. And g of 0 would equal just negative 3, because it would make both of those 0. So we would say 0, and then it would be minus 3, so your answer would be minus 3 for that one. All right, then I was going to do some of the problems from the school city review. So they're the ones that were definitely, most similar. All right, so, and some of them are a little bit of a repeat, so that's all right. So this is just subtraction, but this one's a little bit more like the Celeb than maybe the one on the other sheet. So we just need to take the 7x cubed minus 10x squared minus 5, and just make sure you put it in parentheses, and then we can subtract this other function. The one that really needs to be in parentheses is the one on the right, because you just want to make sure you distribute the negative sign to all those. So I'm just going to do a little mental math there. These two would give you the 5x cubed, and then the negative 10x squared minus the 7 would give you the minus 17x squared, and minus 5 minus minus would give you plus, so negative 5 plus 9 is the positive 4. Okay, this is multiplication. This one's another kind of repeat. Probably don't really need to do this one. When you multiply them, you should get this. I think you're probably good on that one. Okay, this is profit. So pretty similar. I'm just going to work it just so you can remember if you put this on the review. So profit is going to be revenue minus cost. So it's R of X. So I'll just write it this way. P of X equals the revenue, so money coming in, minus the money going out, which were the costs of things, in a business. So P of X would be equal to the cost, so that would be, would be the revenue. So revenues first, so money coming in, so that would be 25X, and then minus, and then 1,500 plus 10X. And then again, you just want to make sure you distribute that negative sign. So the profit function would be 25 minus 10x, so that would be 15x, and then minus 1,500. Okay, got to do that one last. That's a bear. Okay, 5, this one... it's a repeat, but it's more similar to the one on the Celeb. So let's go ahead and do this one. So I'm going to multiply this times this. I'm going to put the little binomial first. You know, the order doesn't matter, but I like to do the little binomial on the left. And then we're multiplying it by the 2x squared plus 3x minus 1. Okay, so you're just going to distribute. So this gets multiplied by everything, and then the negative 1 gets multiplied by everything. So it'd be 2x cubed plus 3x squared minus x. Then distribute the negative 1, so that would be minus 2x squared. Notice I'm putting it underneath the like term. Then this would be minus 3x, and then it would be plus 1. Put a bar underneath it, and you can just combine the like terms. So we got 2x cubed, we got plus 1x squared, we got minus 4x, and then plus 1. So bam, it's that one. All right, this one, again, we kind of did one like this earlier, that one, because it was on the sheet. So I'm going to do this one, though. So g of 3, so we figure out what that one is first. Ooh, maybe not. Oh well, I'll try it. So g of 3, let's figure out what that is. So g of 3, that equals square root of 3. So there's really not much you can do, just put the 3 in there. So now let's say that we're looking for f of the square root of 3. So we're going to take the square root of 3 and put it in there. So f of the square root of 3 is equal to the square root of 3, and we would have to square it, plus 16. And we know that when you have the square root and you're squaring something, they undo each other. So that's 3 plus 16, and that's where we get the 19. Okay, this one's a repeat. I would say, you're just taking this function and you're subtracting that function. You just want to make sure, again, that you distribute the negative sign. If you do, you'll get that answer. All right, this is kind of a repeat too, so I'm not going to work all these out. But the question is basically saying, hey, we added a couple functions together and we got this. Which of the functions, could this work for? So for example, if you took these two functions and you added them together, so 7x plus 3 plus the 7x squared minus 18x, if you added them together, you would get this. So you can see you have 7x squared, you've got 7x minus 18x, so minus 11x, and then you'd have the plus 3. So that's working for, these three functions. When you add them together, you get this. The other functions, no. I put this one on the review just because it was one of these like select all that apply, and those are always harder for people to get right. As you can tell, look at this, 17%, and it's not crazy hard. You're just adding functions together, but it's just details. Okay, so 9, we did one division, but this one's kind of worth doing just because I wanted you to see how it works. So we would take this function, 2x squared minus 2x minus 12 over the x squared minus 5x plus 6. Now at first glance, you're like, oh dang, this is one of those really hard, factoring problems. But it's really not hard at all if you factor out the 2. So then it would be x squared minus x minus 6. And then I'm going to go ahead, I'll factor the bottom in a second, so I'll just leave it. Okay, so now you can tell that you can factor the top and bottom a lot easier. So carry the 2 along for the ride, and then do a double bubble with what's left there. So you got x and x, and then two numbers that multiply to be negative 6 and add up to be negative 1. So that would be negative 3, and that would be plus 2. Then on the bottom, you're looking for two numbers that multiply to be 6 and add up to be negative 5. So that would be, that would be negative 3 and negative 2. And then we can see there's a common factor, and then the answer is, what's left. So then you can multiply these together. You can multiply this back together. So that would be 2x plus 4 over x minus 2. And x can't be 3, that's what this is. X can't be 3, meaning like we canceled out the factor, but that still means you're not allowed to plug in a 3 still. It's an excluded value. All right, so I had a note. I was going to do 18 and then come back to 4. Okay, we got like a rocket one. It's kind of like this, okay? So we got this toy rocket. So this is a graph, Joey's toy rocket, and then this is another graph that we're comparing it with. So go ahead and graph that one on your calculator, and it would look like this. It would have a maximum at 2, and it would go up to 8. And then it would hit the ground right here. So it would have a high point right here at 2.8. So I know everybody can plug that in your calculator, no problem. And that's what you get. So then you start answering the questions, comparing the graphs. So Kim's, which one's Kim? This is Kim. Kim's toy rocket reached a higher height than Joey's. That's true, because Joey's only reached 4 and Kim's reached 8. Both toy rockets reach a maximum at 2 seconds. Yep, so right at 2 seconds, you can tell that's when they reach their maximum. And they both hit the ground at the same time. So they both hit right at 4. They have a height of 0 right there at 4. Okay? All right. Now back to the hideous one. Okay. So I am going to do this one. I'm going to say there isn't one quite as hard as this, but there's a little piece of the problem that's helpful to talk about. Just know it's not quite like this, but just I'll kind of try to point out what is similar about it. Where is that one? What number was that one? Oh, it was 4. That's right. Sorry, I think I could have, maybe I could have paused this, I don't know. Come on. Okay. All right. So, oops, almost there. All right. So this is a car value right here. And she's putting money. It's like really confusing to figure out even like what the heck they're talking about. So the car is losing value, of course. So the car is losing value. So let's just kind of talk about that first. So whenever you want to figure out like a percent that something is going up, like it's increasing or decreasing by, what you do is you figure out, there's a little equation for this. So if you ever wanted to figure out like, hey, I need to figure out the percent of increase or decrease, okay? So it's the percent of increase or decrease is equal always to however much it actually increased. So it's the amount of increase or decrease. And then it's over the original amount. So this is the amount of increase or decrease. Oh my gosh, how did that disappear? Sorry. All right, so percent of increase or decrease is equal to the amount that it actually went up or down divided by the original amount. So for example, for this one, how much did it go down? So it went down $3,000. So you take $3,000 and you divide it by whatever the original amount was, and that's $20,000. So 3,000, oh, now it's gonna give me troubles. Oh my gosh. 3,000 divided by 20,000, that's a 0.15, so that means that's a 15% decrease. It keeps depreciating 15%, okay? So what we could do is we can make ourselves like a nice equation, and we could say, hey, all right, it's starting off, here it is, it's starting off at $20,000, and remember how we did that 1 minus whatever the percent decrease is, so we did this, and then we had the years, you know, as the exponent. Well, then this would be y equals, and it would be 20,000, and that would be 0.85, right? Well, this is 5 years. We were trying to figure out, like, hey, after 5 years, it says after 5 years, Chelsea sells the car for its current value. So let's go ahead and we're going to put a 5 in here for the years. And that tells me that the car is going to be worth 8, 8, 7, 4, and 11 cents. Now, then what she says is, hey, what I'm going to do is I'm going to take this money, I'm going to sell the car, and I'm going to put it into the savings account, okay? So off to the side, let's see what's been happening to her savings account, this one here, after 5 years. So that represents her money. So she put $1,000 in. It's a 3% increase. So they did 1 plus 3%. They got 1.03. So let's figure out how much money she has in savings after 5 years. Okay, so that's 1.03, raising it to the 5 years. That she would have 11.59 and 27 cents. Okay. So what she said was she was going to sell the car, she was going to put it into the savings account. So now what she's doing is for the last couple of years, because it says 2 years after that, we want to figure out how much money she would have after 7 years. So after 5 years, she sells the car, she puts the money into the savings that she already has. So we need to add these two amounts together. And that starts like a new, if you want, like a new principal, a new starting amount. So it'd be y equals, I added those two together and I got 10,033. There's your new principal amount, okay? And it's still that same savings account. So it's 1.03, and it's going to be in there for 2 more years. So when you do the math on that, it turns out to be 10,644, and it was like exact. It was like 0.00. So that's it. Okay. So I have one more thing to show you, and we are done. Okay. One more thing. Oh. Oh no. Is it not going to work for me? Let's see. Oh no, it's not going to work for me. Wait, maybe. No? Oh well. All right, I wanted to say that was easy. Booger, it's not going to work. All right, good luck. Study these problems. Later.